Okay, so now we are doing today's daily Leetcode problem. 926 flip string to monotonous increasing. Okay, so this is a nice question. You have been given a string. It's a binary string, only contains 0 and 1, and it is a monotonic string increasing. Okay, so it can be anything, but you want to make it monotonic increasing. Okay, so monotonic increasing is what where there are some number of zeros, possibly none or like all, and followed by some number of ones. So there would be some zeros and then followed by some ones. So that is called a monotonically increasing string, right? Some zeros and some one. And then you are given a binary string. You have to tell you can flip any character from 0 to 1 or 1 to 0, such that you can create a monotonically increasing string. So you can flip the 0 to 1 1 1 and 0 0 0 0. Now this is but you want to create a monotonic string. So for an example, let's take the examples, right? Do you get the idea what the question is about? The question is about, you have been given a string, you want to make it monotonically increasing. What is a monotonic string? It can contain any number of zeros and then any number of ones. Okay, this is the monotonic string. So this is what you want to convert, and now this is all about the question. And then you have to return the minimum number of flips needed to make the given string into a into a monotonic string, right? This is all about question. Let's take example. So 0 0 1 1 1 0. So in this case, how can you create it monotonically increasing? Multiple ways are there. The simple way is to create this 0 to 1, to convert this 0 to 1. It will become monotonic increasing because some zeros are there and some ones are there, right? So now let's start how we are doing this. The logic for this problem is would be uh, okay, so in these cases, you can just count minimum number of zeros or one kind of that thing also, because in this case, minimum number of zeros and ones is all three, but you want only two operations to convert this into a monotonic string. What those two operation can be: convert this to one and convert this to one, and now all ones and this 1 0, right? This is a possible one way. Other possibility is to convert this to 0 and this to 1. Also one possibility with the two number of operation. So what I'm doing this, not let's talk about logic. Logic for this problem would be just simple and straightforward, that you will be going over all the possible monotonically introducing string possible. Okay, and still you can do it in O of n time. Why? The reasoning for this I can give, it's very short and simple. Like for example, there this is also how many monotonically increasing strings are possible, right? So let me tell you, there are only just if the length is n, if your original string length n, then string monotonic, let me write this mono string of length n is equal to just n, right? So this is why you can do this. This is not up to n square or n ki power n or something like that. It's just this. So first is this string. Okay, I'm writing those n monotonically string for length n, 0, all zeros and this just one in the last, all zeros just two ones in the last, all zero three ones and then four ones and then five ones and then all ones. Okay, these are the possible monotonic string. So you need to see the your string. Okay, your string, okay, this is your string, and compare your string with each of the string, okay. Compare your string with each of this and tell minimum difference, right? Now there are multiple ways to do this. My way of doing this, let me tell you how I did this. I started with my original given string. It could be better if I can take an example. So let's take the 6 length example, or let's take the, yeah, biggest one maybe, right? Let's take the biggest one. Yeah. Now what I did, I calculated total number of ones in this. So total number one is equal to 2. That is the difference between this string and this all zero string, right? Because you can just flip these two ones to 0 0, then it will become all zero. Total number of ones is 0. Then what I did, I checked, this is my initial number. Then I checked whether my last digit is 1 or not. Okay. If it is 1, then it is matching with this, right? So just decrement this count to, let's say, 1, because let's say what I am saying, that this is my initial string, your initial answer is 0. I'll be checking that whether your last number, is it 0 or is it 1. It is actually 0. So what I will say, don't you can't like now I'm making it equal to this one. So for making it equal to this one, like all zeros and then just one in the last, uh, the difference between these is now 3, because these two ones are here, these two zeros, and this is 0. So what I'm saying, check whether your last number is 0 or 1. If it is 0, then increment this count 1, it becomes 3. Now let's check your second last number. Is it equal to 1 or not? Because now I'm checking it with two ones, right? This is already calculated, so this is the answer for that part. It could be, if it was just 1, then it would be 2, but now it is 0, so that's why this is 3. Now I'm checking the second digit. Is second digit equal to 1? If it is equal to 1, then it is helping me to make that string, right? Then I'll decrement this. I'll minus this 3 to 2. Because if it was 1, then why will minus this? 2 and then plus 1 for that, and I'm saying in this 2 operation you can do this. Is it so? I don't know. I think you don't decrement that. Okay, if it is 1, you have to decrement that also. 2 plus 3. hmm. And this, can we do it in just one operation? No. How many operation does this require? I think it would take one and one, two operations at least. Yeah, so that's what I'm saying now. Okay, currently your answer is 3. Decrement this 3 minus 1 is equal to 2. Yes, I can make this good in two, just two number of changes, 1 and then this 2, right? So now it is also good. But yeah, that we'll do, and we'll just keep on iterating. Then let me just draw like index wise now, if you got the idea. So current answer for this string is equal to 2. Then I'm taking this index I. If it is 1, I'll minus that. If it is 0, I'll plus that. So the 2 plus 1 equal to 3. So now the answer for this is minimum answer. This is still 2, but I'm trying to make it into something like, all zeros and last one. So last one you have to convert this also. You have to make these two as 0 also. So that is thing. So then the answer would be saying you will just decrement your I. It will give you something because minimum answer you already got. Minimum answer for this is 2, and that you already got. So that is the thing, and this c will always be taking mn is equal to minimum of mn comma c. So currently my c pointer is equal to 3, c pointer 4, 5, 6. I think, no, 3 after this it become 3, then it will become 4, and then it will remain 4 up till these two indexes. No, it will minus 2. It will just minus 1 and minus 2. Why minus 1 minus 1 equal to minus, it will become 2, because then you will say, okay, I'm making all these as one, right? So that is also a good way. And if you go one more back, you are saying that I'm going to make all these equal to 1. That would take you 3 operations, so that's why plus 1 for that, and still so on, plus 1 and plus 1. So at last it will become something like 4, 5, 6. Minimum answer you got in the whole observation is just 3. So this is the logic. Convert this string, not convert the string, just calculate the number of ones in your string, and then start iterating from the backwards. Whenever you get 1, do counter minus, do counter plus. So that's what I did over here. Let me just quickly do it again. So it would be something like enter, how to check number of ones. Okay, so that is also the thing. But currently what we can do is just for auto I in this, yeah, is equal to 0 for auto I in string. If that is equal to 1, we'll do c plus plus, and this is your total number of counter c ones in the string. And then you start iterating from the back. Equal to n minus 1, and then equal to 0, I minus minus. If it is good, like if it is 1, s of I is equal to 1, and you'll do c minus minus. Else you do c plus plus, and you do minimum is equal to minimum of c mn comma c every time. And mn is equal to initialized with c, because that is the you know answer which you are getting in beginning. Return mn, and that's all about it. See, n is not declared, I think, right? Now it is. So that's all about it. Try to sum this up. Initially what I was doing, I was just doing something like checking the total number of ones or zeros, but that's what not a good approach. This was a good approach, because essentially what I'm doing over here, I'm just checking my original string and comparing with every other possible string. So there is no way it can go wrong, because I'm checking with all possible monotonically increasing string and taking the minimum difference from any one of that. What also you can do, you can generate those string, but I don't think so like it will be possible, because 10 raised per 5 is the length, and yeah, into 10 raised per 5, because you will need an array of 10 raised per 10 to store that much string, and then to check whether each possible string, how much difference is there. So this is the logic for checking that. Okay, so that's about it. Okay guys, bye.